Hi, and welcome to the quick start video for the BOP series of linear power supplies by KEPCO. BOPs are linear power supplies, available from 40 watt to 400 watt configurations. Voltage configurations range from 5 volts to 1000 volts, and current configurations range from 40 milliamps to 30 amps. We'll discuss the advantages of using BOP supplies and learn how to quickly begin using the product. But before we do that, let's discuss what BOP means. BOP stands for bipolar operational power. Bipolar means that the BOP supplies can operate in all four quadrants of the power chart, positive and negative voltage, and positive and negative current. Bipolar functionality, originally invented by KEPCO, is achieved without any relays or output polarity switching, giving the BOP supplies a major advantage: a totally smooth zero crossing. With a smooth zero crossing, transitioning to any voltage or current is smooth and continuous, resulting in no interruptions to loads. Bipolar operation also allows the BOP supplies to act as both a power source and power sink when needed. Every BOP unit is backed by a 5-year warranty and the full support of KEPCO's expertise. Here we have an unpackaged BOP unit. This is a 20-10 model rated for 20 volts and 10 amps. All BOP units come with a power cord, front panel sense links, rear sense links already attached from the factory, and a PC15 connector that plugs into the rear of the unit. This PC15 connector is a must. The unit will not work without one. These connectors are kind of like personality cards for the BOP. Depending on the way the card is configured, the BOP can behave differently, like acting as an amp or setting voltage current limits for a specific use case. Every unit ships with a standard PC15 connector configured for the front panel controls. Right away, you can see what sets the BOP series apart from other power supplies. Not only are there simple and easy to use controls, but all the unit's inputs and outputs are accessible from the front rather than just the rear. At the center of the front panel is a multifunction LED. By default, it indicates output status, but indicates remote status with a GPIB or Ethernet card installed. More details on this functionality can be found in the operator's manual. As for the controls, in the center is the voltage mode current mode switch. On either side of that switch are the voltage control and current control switches. These switches, along with their respective knobs, allow setting the desired output voltage or current. Next to the output terminals are the voltage limit and current limit potentiometers, which allow setting negative and positive limits for both. These limits are active regardless of the unit's mode of operation. Next to the limit potentiometers are the programming inputs. These inputs allow the BOP to act as an amp, reflecting the input waveforms at the output with the appropriate gain. For both inputs, a 10-volt input signal will be reflected at the output at the nominal output value. For example, with the 20-10 model, a 10-volt amplitude sine wave at the voltage programming input will produce a 20-volt amplitude sine wave at the output. On the rear, you can access the unit's output terminals as well as the PC15 connection. If a unit is ordered with the optional GPIB or Ethernet boards, the relevant ports will also be available next to the PC15 connection. At the top is access to a number of potentiometers which can be adjusted for calibration, but all units are pre-calibrated from the factory. After plugging the unit in, make sure the voltage control and current control switches are in the off position. Now just flip the circuit breaker on the front and it will power right up. To operate the unit in voltage mode, make sure the center switch is set to voltage. The LED on the voltage side is on, indicating the BOP's mode of operation. Then, flip on the voltage control switch. You can now set the desired voltage using the knob. Turning the knob clockwise increases voltage to 5% above the nominal value. Turning it counterclockwise decreases voltage to negative 5% above the nominal value. In this model's case, the nominal value is 20 volts. Since I have a resistive load of 2 ohms attached, you can see the current change as the voltage changes. To operate in current mode, ensure the BOP has a resistive load attached and turn off voltage control. And flip the center switch to current mode. Now the current mode LED turns on. Next, enable the current control switch. The current controls work exactly the same as voltage mode. Clockwise increases current to 5% above the nominal value, and counterclockwise decreases current to negative 5% above the nominal value. In this model's case, the nominal value is 10 amps. To show that BOPs have truly smooth zero crossings, here we have the BOP acting as an amp. It's currently set to voltage mode with voltage control disabled, and a function generator inputting a sine wave into the voltage programming input. Any signal sent to the programming input will be reflected at the output. The input signal can be seen at the top, while the BOP output can be seen on the bottom. The BOP's displays do not appear to show the waveform. This is because the waveform being used is simply too fast for the display. Normally, the output waveform is both out of phase and scaled to the appropriate gain. But for the purpose of this demonstration, the output waveform is both scaled and inverted on the oscilloscope to match the input waveform. Looking at this oscilloscope image, we can see that the resulting sine wave is free of distortion and matches up exactly with the input waveform. This can be done with any arbitrary waveform. Here is a square wave, a triangle wave, and a sawtooth wave. All results are distortion-free and complete. BOPs are also incredibly customizable and flexible. For specific reactive types of loads, BOP units can be ordered with inductive or capacitive load optimization. BOPs can also be ordered with GPIB or Ethernet for remote access and control, which can be used with an existing EPIC setup with the proper drivers. Even the standard PC15 connection allows access to multiple flags and functions for different use cases and custom control parameters. It also has excellent low noise and low ripple performance. BOPs are great for use in magnetics, simulation and testing, and laboratory applications due to its incredible flexibility and performance. That wraps up this video, but for more information on the BOP series or any other products, go to kepcopower.com.